Graphs Deployment Introduction. Graphs deployment is the process of deploying graph-based applications, graph databases, and graph APIs into production environments. In software engineering, graphs can mean graph data structures, graph algorithms, graph databases, knowledge graphs, social graphs, recommendation graphs, dependency graphs, fraud detection graphs, network graphs, relationship-based search systems. A common learning topic is how can developers deploy graph-based systems in real-world applications? This guide explains graph basics, graph database deployment, Spring Boot plus graph database integration, Docker deployment, Kubernetes deployment, graph API design, data import, indexing, scaling, monitoring, backup, security, CI/CD, best practices. This is one of the best practical guides for backend developers, full-stack developers, and cloud-native engineers learning graph deployment. Neo4j's official documentation lists deployment options including fully managed and self-managed deployments, with support for Docker and Kubernetes. Neo4j also provides Docker and Kubernetes operations documentation, and Spring Data Neo4j provides repository support for Neo4j graph database applications in Spring. Simple definition. Graphs deployment means running a graph-based system in a real environment where users and applications can access it. Simple idea. Graph data, graph database, Spring Boot graph API, front-end, other services, production environment. Example. Users follow other users. Relationships stored in graph database. Spring Boot API queries recommendations. React UI displays suggested friends. A graph is a structure made of nodes and relationships. Example. Numon means follows, means John. John means works at, means company. Company means located in, means Toronto. Graph contains dot. Graph part meaning node entity relationship, connection property, data on node or relationship, label, node category, query, search, traverse graph. Example nodes. Check. User, product, company, article, city, order. Example relationships. Comma, purchased, worked at, likes, related to, located in. Why deploy graph systems? Graphs are useful when relationships matter. Common use cases. Social, networks, recommendation engines, fraud detection, knowledge graphs, dependency analysis, route planning, network topology, access control systems, product recommendations, customer 360 systems. Example. Relational database. Find user orders. Graph database. Find users similar to this user through shared interests, purchases, and locations. Graph database versus relational database. Feature, relational database, graph database. Main concept, tables and rows, nodes and relationships. Best for, structured transactions, connected data. Query style, SQL joins, graph traversal. Relationships, foreign keys, first-class relationships. Examples, PostgreSQL, MySQL, Neo4j, JanisGraph. Amazon Neptune, common use orders. Payments, users, recommendations, networks, fraud. Simple rule. Use relational DB for transactions. Use GraphDB when relationship traversal is the main problem. Graph deployment architecture. Typical architecture. React frontend. Spring Boot API. Graph service layer. Graph database. Persistent storage. Cloud native architecture. Front end. API gateway. Spring Boot graph API. Neo4j graph database. Kubernetes persistent volume. Monitoring plus backup. Step 1. Choose graph deployment type. Common deployment options. Deployment type best for local Docker, learning and development. Docker Compose, local full stack setup. Kubernetes standalone. Small production workloads. Kubernetes cluster. High availability. Managed cloud. GraphDB. Less operations burden. hybrid enterprise environments. Beginner recommendation. Start with Docker Compose. Then learn Kubernetes deployment. Then learn managed cluster deployment. Step 2. Choose graph database. Common graph databases. GraphDB common usage. Neo4j popular property graph database. Amazon Neptune AWS managed graph database. Janus Graph distributed graph database. ArangoDB multi-model database. TigerGraph large-scale graph analytics. MemGraph real-time graph analytics. For Java Spring Boot beginners, start with Neo4j plus Spring Data Neo4j. Spring Data Neo4j provides repository support and a familiar Spring programming model for Neo4j-based applications. Step 3. Local graph database deployment. Using Docker. Docker run name Neo4j, name 7474 7474, name 7687 7687, Neo4j auth, Neo4j password, Neo4j latest. Ports. Port purpose 7474, Neo4j browser, HTTP UI 7687, Bolt driver connection. Access browser, http://localhost 7474. Neo4j's Docker documentation explains how to deploy a Neo4j server using Docker Compose, set up authentication, and use Docker-specific operations. Step 4. Docker Compose deployment. Example. Services. Neo4j. Image. Neo4j latest. Container name. Neo4j. Ports. 7474 7474. 7687 7687. Environment. Neo4j auth, Neo4j password. Volumes. Neo4j data/data. Neo4j logs/logs. Volumes. Neo4j data. Neo4j logs. Run. Docker Compose up-d. Check logs. Docker logs Neo4j. Step 5. Persist graph data. Graph database data must be persistent. Bad. Run a database container without volume. Container deleted means data lost. Better. Use Docker volume or Kubernetes persistent volume. Docker volume. Volumes. Neo4j data. Neo4j provides Docker mount points for storage, including storage-related directories, to simplify using Neo4j in Docker. Step 6. Spring Boot Graph API. Spring Boot app connects to Graph database. Architecture. Controller, service, repository. Neo4j. Example package structure. SRC, main Java, COM, example graph. Controller, service, repository, node, relationship, DTO, config. Step 7. Add Spring Data Neo4j dependency. Maven. Dependency, group ID, org.springframework.boot, group ID, artifact ID, Spring Boot Starter Data Neo4j, artifact ID, application config, Spring Neo4j, URI, Bolt, localhost 7687, authentication, username, Neo4j, password. Step 8. Create graph node. Example. @node user. Public class user node. @id, @generated value, private long id. Private string user ID. Private string name. Private string email. Public user node. Public user node, string user ID, string name, string email. This.userid equals user ID. This.name equals name. This.email equals email. / getters and setters. Node means a graph entity. Step 9. Create relationship. Example. @relationship properties, public class, follows relationship. @relationship ID, private long ID. Private instant followed @ target node, private user node, target user. Public follows relationship. Public follows relationship. User node target user, instant followed @ this target user equals target user. This followed @ equals followed @ getters and setters. Relationship means connection between two nodes. Example. User A means follows means user B step 10. Repository layer public interface user graph repository extends Neo4j repository user node long. Optional user node find by user ID string user ID. List user node find by name containing ignore case string name. Custom query @query.match user follows friend user where user ID equals user ID. Return friend. List user node find friend string user ID. Step 11 service layer @service public class user graph service. Private final user graph repository user graph repository. Public user graph service user graph repository user graph repository. This.user graph repository equals user graph repository. Public user node create user request request. User node user equals new user node request.user ID request.name request.email. Return user graph repository .save user. Public list user node find friends user ID. Return user graph repository find friends user ID. Step 12 REST controller @REST controller @request mapping API graph users. Public class user graph controller. Private final user graph service user graph service. Public user graph controller user graph service user graph service. This user graph service equals user graph service. @post mapping public user node create user @request body create user request request. Return user graph service create user request. Get mapping user ID friends public list user node friends @path variable string user ID. Return user graph service find friends user ID. Step 13 graph API endpoints. Example endpoints. Post API graph users post API graph users /user ID follow /target user ID. Get API graph users /user ID friends. Get API graph users /user ID recommendations. Get API graph products /product ID similar. Use cases. Social graph, recommendation graph, products graph, knowledge graph, dependency graph. Step 14 graph query example. Cipher query match user dot friend user where u.user ID equals USR 101. Return friend. Recommendation query match user user ID not follows a subset user to suggested where not you follows a suggested and you are not suggested. Return suggested count as score order by score desk limit 10. Meaning find people followed by my friends but not already followed by me. Step 15 data import. Graph systems need data import. Common sources. cat CSV files, cat relational database, cat event streams, cat APIs, cat data warehouse, Kafka topics. Example CSV import idea. Users.csv, relationships.csv, products.csv, orders.csv. Import flow. Source data, ETL job, validate data, create nodes, create relationships, build indexes. Step 16 graph indexing. Indexes improve query performance. Example. Create index, user ID index, if not exists, for user on u.user ID. Product index. Create index product ID index, if not exists, for p product, on p product ID. Why indexing matters. Check. Faster lookup. Check. Better API response time. Check. Less database load. Scalable query performance. Step 17. Graph data model. Example, social graph. User follows to user. User likes to post. User located to company. Example, product graph. User purchased, similar to, product, category. Product, similar to, product. User viewed. Step 18. Dockerize Spring Boot Graph API. Docker file. From Eclipse Temurin 21-JRE. Work dir app. Copy target graph API.jar. App jar. Expose 8080. Entry point. Java -jar app jar. Build. Docker build -t graph API 1.0.0. Run. Docker run -p 8080 graph API.1.0.0. Step 19. Docker compose full stack services. Graph API. Build -graph API. Ports 8080. Environment. Spring Neo4j URI. bolt.neo4j.7687. Spring Neo4j authentication username, Neo4j. Spring Neo4j authentication password, depends on Neo4j. Neo4j image, Neo4j latest. Ports 7474, 7687, 7687. Environment, Neo4j auth, Neo4j password. Volumes, Neo4j data/data. Volumes, Neo4j data. Important. Inside Docker Compose, use service name Neo4j, not localhost. Step 20. Kubernetes deployment. Graph API deployment. API version. apps/v1. Kind deployment. Metadata. Name graph API. Spec. Replicas. Match labels. App graph API. Template. Metadata. Labels. App graph API. Containers. Graph API 1.0.0. Ports. Container port 8080. Env. Name Spring Neo4j URI. Value. bolt./Neo4j 7687. Service. API version. v1 kind. Service. Metadata. Name graph API spec. Selector. App graph API. Ports. Port 8080. Target port 8080. Neo4j's Kubernetes operations manual includes quick starts for deploying standalone and cluster instances using Helm charts, persistent volumes, SSL, authentication, plugins, and ingress access. Step 21. Neo4j Kubernetes with Helm. Common flow. Helm repo add Neo4j. https://helm.neo4j.com/Neo4j. Helm repo update. Install example. Helm install Neo4j, Neo4j/Neo4j. -set Neo4j.name equals Neo4j. -set Neo4j.password. Helm is commonly used to package and deploy Kubernetes applications. Neo4j provides Helm chart documentation for standalone and cluster deployments on Kubernetes. Step 22. Persistent volume in Kubernetes. Graph databases need persistent storage. Bad. Graph database pod restarts and data disappears. Better. Use persistent volume claim. Example idea. Volume mounts. Name Neo4j data. Mount path/data. Persistent volume claim. API version v1. Kind persistent volume claim. Metadata. Name Neo4j data. Spec access modes. Read write once. Resources, requests, disk storage, 50 GI. Do not hardcode passwords. Bad. Neo4j password. Password 123. Better. Use Kubernetes secret. Secret. API version v1. Kind secret. Metadata name Neo4j secret. Type opaque. String data Neo4j username Neo4j. Neo4j password change me. App env. Env from. Secret ref. Name Neo4j secret. Step 24. Health checks. Spring boot actuator endpoints. Actuator health. Actuator health readiness. Actuator health liveness. Kubernetes probes. Readiness probe. HTTP GET. Path actuator health readiness. Port 8080. Liveness probe. HTTP GET. Path actuator health liveness. Port 8080. Why important? Say, Kubernetes routes traffic only to ready pods. Unhealthy pods can restart. Deployment becomes safer. Rollout can be monitored. Step 25. Monitoring graph deployment. Monitor graph API. Check. Request latency, error rate, CPU, memory, connection pool, slow graph queries, failed queries, API throughput. Monitor graph database. Circle memory usage, disk usage, query latency, active connections, transaction count, page cache usage, storage growth, backup status. Tools. Check. Spring Boot Actuator. Check. Micrometer, Prometheus, Grafana, Neo4j metrics, Kubernetes metrics, OpenTelemetry. Step 26. Backup strategy. Graph database backup is critical. Backup should include graph, data, indexes, constraints, configuration, import files if needed, deployment values, secrets stored separately, backup plan, daily backup, weekly full backup, point-in-time strategy if supported, restore test monthly. Important. Backup is not complete until restore is tested. Step 27. Scaling graph applications. Scale API layer. Increase Spring Boot graph API replicas. Scale database layer. Use proper GraphDB clustering or managed service. Important. Scaling API pods is easy. Scaling graph database writes is harder. Consider curse, read-heavy versus write-heavy workload, touch, query complexity, index design, caching, database memory, storage speed, clustering support, graph traversal depth. Step 28. Caching strategy. Cache common graph results. Check recommendations, friend suggestions, product similarity, frequently viewed graph paths, graph summaries. Example. Get API graph users 101 recommendations. Check Redis cache. If cache miss, query GraphDB. Cache result for short time. Be careful. Graph relationships change. Cached recommendations may become stale. Step 29. Security. Graph deployment security includes database authentication, strong passwords, network restrictions, TLS/SSL, role-based access, API authorization, secrets management, input validation, query limits, audit logging. Important. Do not expose graph database directly to the public internet. Expose it through backend APIs. Good. Frontend means Spring Boot API means graph database. Bad. Frontend means graph database directly step 30, CI/CD for graph deployment. Pipeline. Pull request. Run unit tests. Run graph integration tests. Build Spring Boot jar. Build Docker image. Scan image. Deploy graph API. Run smoke tests. Graph database deployment. Helm values update. Kubernetes deploy. Health check. Run migration index scripts. Verify graph queries. Real-world example. Recommendation graph scenario. E-commerce app wants product recommendations. Graph model. User viewed. Product. User purchased. Product. Product. Similar to. Recommendation logic. Find products purchased by users with similar behavior. Architecture. React product page, dash, Spring Boot recommendation API, dash, Neo4j graph database. Endpoint. Get, API, recommendations, users, user ID. Response. Product ID, P100. Name, wireless mouse. Score, 0.91. Real-world example, social graph. Graph model. User follows to the user. User likes to the post. APIs. Get API users.id followers. Get API users.id following. Get API users.id suggested friends. Suggested friends query. Friends of friends. Common groups. Common interests. Real-world example. Dependency graph. Use case. Cloud-native microservice dependency tracking. Graph model. Service. Calls to service. Uses. Database. Publishes. to topic. Service, consumes, to topic. Useful for, check, impact analysis. Check, incident debugging. Check, dependency mapping. Check, release planning. Check, architecture review. Question: if payment service fails, what services are affected? Graph Query can answer this quickly. Common beginner mistakes. 1. Using Graph Database for everything. Bad. Put all transactional data only in GraphDB. Better. Use Relational DB for transactions. Use GraphDB for relationship-heavy queries. 2. No persistent storage. Bad. Run GraphDB container without volume. Better. Use Docker Volume or Kubernetes PVC. 3. Exposing database publicly. Bad. Internet means Neo4j. Better. Internet means API Gateway means Spring Boot API means Neo4j4. No indexes. Graph queries can become slow without proper indexes. Create indexes for lookup properties like user ID, product ID, email, slug. 5. Publishing internal entities. Bad. Return full graph node entity directly from API. Better. Return DTO response. 6. Ignoring query depth. Very deep graph traversal can be expensive. Limit traversal depth and result size. 7. No backup and restore test. Backup without restore testing is risky. Best practices. Start with clear graph use case. Model nodes and relationships carefully. Use GraphDB for relationship-heavy problems. Use Spring Boot API as access layer. Do not expose DB directly. Use Docker Compose for local setup. Use persistent volumes. Use Kubernetes secrets. Configure health checks. Create indexes. And constraints. Monitor slow queries. Cache expensive graph results. Limit traversal depth. Use DTOs for API responses. Test graph queries. Automate deployment with CI/CD. Backup regularly. Test restore process. Graph deployment interview questions. 1. What is a graph? A graph is a data structure made of nodes and relationships. 2. What is graph deployment? Graph deployment means running a graph database or graph-based application in a real environment, such as Docker, Kubernetes, or cloud. 3. When should you use a graph database? Use a graph database when relationships and traversals are central to the problem, such as recommendations, social networks, fraud detection, and dependency analysis. 4. Graph database versus relational database. Relational databases are table-based and good for transactions. Graph databases store nodes and relationships and are good for connected data. 5. Why use Spring Data Neo4j? Spring Data Neo4j provides repository support and Spring-friendly integration with Neo4j Graph Database. 6. Why is persistent storage important? Without persistent storage, graph data can be lost when containers or pods are deleted. 7. How do you secure graph deployment? Use authentication, network restrictions, secrets, TLS, API authorization, and avoid exposing the database publicly. 8. How do you improve graph query performance? Use indexes, constraints, query profiling, caching, traversal limits, and good graph modeling. 9. How do you deploy graph database on Kubernetes? Use stateful set or Helm chart, persistent volumes, secrets, services, and health checks. 10. What should be monitored? Monitor query latency, database memory, disk usage, API latency, connection count, slow queries, storage growth, and backup status. Graph deployment roadmap, beginner level. Learn graph basics, nodes, relationships, graph database basics, local Docker deployment, basic Cypher queries. Build. Simple social graph, intermediate level. Learn Spring Data Neo4j, REST APIs, Docker Compose, indexes, query optimization, data import. Build Spring Boot Recommendation API, advanced level. Learn Check Kubernetes deployment, Helm charts, persistent volumes, backups, monitoring, security, graph scaling. Build Production-ready graph recommendation platform. 30-day learning plan. Week 1. Graph basics. Learn. Check. Nodes, relationships, labels, properties, cipher basics, graph use cases. Practice. Create users and follow relationships. Week 2. Local deployment. Learn. Docker. Docker Compose. Neo4j browser. Persistent volumes. Basic imports. Practice. Run graph database locally with Docker Compose. Week 3. Spring Boot integration. Learn. Check. Spring Data Neo4j. Graph nodes, relationships, repositories, graph REST APIs. Practice. Build graph API with Spring Boot. Week 4. Production deployment. Learn. Kubernetes, Helm, secrets, persistent volumes, monitoring, backup, CI/CD. Practice. Deploy Graph API and Graph Database to Kubernetes. Graph's deployment is useful for applications where relationships are important. Important concepts include check nodes, check relationships, graph database, graph APIs, Spring Data Neo4j, Docker deployment, Docker Compose, Kubernetes deployment, Helm charts, persistent storage, indexes, monitoring, backup, security, CI/CD. Backend developers already understand. Check APIs, databases, services, Docker, Kubernetes, deployment. This makes graph deployment easier to learn step by step. Key idea. Graph deployment allows developers to run relationship-heavy systems such as recommendations, social networks, fraud detection, and dependency mapping in production-ready environments.